Good morning, third graders. It's Mrs. Belatesh. And before we get started today, I just want to do a review of our vocabulary. So forces, right? Force is what makes things move. And magnetic force was one of the forces that we looked at, and it was a pulling or a pushing force, an attracting or repelling. Gravity pulls everything together down to the surface of the earth. And in order for something to move, we need to have an unbalanced force, right? One force on one side has to be stronger than the other. If things are not moving, we know that there are balanced forces. Okay, we also made a little car. This is a wheel and axle system. And a wheel and axle system, boys and girls, is a type of simple machine. It helps us get work done easier. So this is a wheel and axle system. These are the wheels. This straw is the axle that connects the two. And then we built a slope. We had a slope from the ramp that we built. And one of the reasons that the cars stopped moving after a little while was because of friction. Friction is rubbing force, it's a pushing force, and it causes things to slow down. All right, today we're going to start talking about and building twirly birds. I want you to get this out of your bag, your kit of science materials. And I need you to get a few paper clips. And I want you to get this page from your packet. This is for your science notebook. And it is called Twirly Bird Investigations. For today's lesson, you're going to need maybe some Scotch tape or masking tape. And you're going to need some scissors. So you've got this page called Twirly Birds, and boys and girls, this is the only one you have, so please be careful with it. Do not cut before I tell you what the directions are, okay? So this is called Twirly Bird, and do you notice on the pattern, the Twirly Bird pattern, there are some dotted lines and some solid lines. The first thing we're going to do is we're going to cut down this solid line to separate this into two pieces. So cut on this line right here. Okay, so I've separated mine. I have two. I'm going to put one to the side. Now, when I look closely at my twirly bird, I see there's a solid line here, and there's a very small solid line here. We are going to cut only on those lines. We're going to cut on this line and this line. Why don't you wait and watch me in just a second? So here it is. I've cut this one and I cut these. I did not cut anything else. And now I'm going to fold. I'm going to fold on the dotted lines. The first one I'm going to fold are these long folds here. So this is what I want you to do. I want you to fold it so that it is in thirds, right? And it kind of looks like a paintbrush right now, right? Here's the handle of the paintbrush, and here are the bristles. So now what you're going to do is you're going to fold on this line. You're going to fold one of them away from you, and you're going to fold the other one towards you. Okay, so this is what your twirly bird should look like. Before we start testing our twirly bird, we need to get a paper clip and put one paper clip, just one, on the bottom of the twirly bird. To do that, boys and girls, what you do is you take the rounded part like this and you push the paper clip up onto it like this. So you see here's the one round side and there's the other side. So the paper handle is between the two sides of the paper clip. So this is our standard twirly bird. Now that we have made our first twirly bird, I want us to take a minute and get this piece of paper that says Twirly Bird Investigations, and we're going to glue it into our science notebook on the next available page. Okay, I glued it into my science notebook. I added the date, and I also added a page number. Remember, we're going to make sure that we have the page numbers on each page. That way we don't skip a page, okay? Now, the first question it says, Describe or draw a picture of your standard twirly bird in the empty area below. Be sure to write standard on the body of the twirly bird before going on. So take a minute now and draw a picture of this twirly bird in that little space on that paper. Do you guys remember when we did the experiment using the magnets and we wanted to see what happened to the magnetic force as we added more magnets? Right? We asked a question and then we kind of created a little system or a process that we could follow to find a way to answer that question. So we're going to do something like that this time as well. We're going to use our twirly bird that we just made, and I want to find out if the twirly bird moves differently if we build it in different ways. Now, this twirly bird that we just made is going to be our standard twirly bird. And I'm going to write the word standard on the handle of this twirly bird. So please do that now. Write the word standard. So I've got mine, standard, right there. And now I want us to be able to test this and then make some changes. When we make changes to the twirly bird, we are going to add a variable. A variable is going to be just one thing that we change each time we test the twirly bird. Okay, so boys and girls, I've got my twirly bird and now I want to test it. I'm going to hold it high over my head and I'm going to let go. Awesome. Let's do it again. I'm going to hold it up and I'm going to let go. Okay, let's talk about a little science here. So, does the twirly bird move? Yes. So if it moves, it has what? Unbalanced forces. So what are the forces that are acting on the twirly bird? Let's test it again. Okay, let's try again. Let's put it up in the air, let it drop. So there's definitely something pulling the twirly bird down to the ground. What is it? What is the pulling force pulling it to the ground? Gravity, right. But there has to be something else going on. If it was just gravity, this twirly bird would fall really fast. What else is happening? Let's try it again. The twirly bird comes down a little slower. What is pushing back up against the twirly bird? Air resistance. The wind, the air, the gas in the room is pushing back up against the wings of the twirly bird. Okay, so we now know how the standard twirly bird works, right? Now, I want to make one small change. Now, we can make a couple of different changes, but each team can only do one change at a time. So what are some things we could change about the twirly bird? Why don't you talk about it with your group? I came up with two possible changes. You might have others. One thing I thought is that we could add more paper clips, right? Instead of having one paper clip, we could have two paper clips, and we could see how the twirly bird acts with that. The other choice is that we could cut the wings shorter, and we could see how the twirly bird acts with that. You might have some additional variations or variables. So now that we have at least two variables, this is what we're going to do next. Letter B, write a focus question. So my focus question will be, if I add an extra paper clip, what will the twirly bird motion be? Question mark. So you can write your own focus question. If I cut the wings shorter, how will the twirly bird move? Okay, so now you need to make a prediction about what you think is going to happen to the twirly bird based on your change, your variable. Again, I think I'm going to do the paper clip, and I said, I think the twirly bird will fall faster. But I'm not done. I need to say because the pull of gravity will be more than the push of air resistance. And then, right, I have unbalanced forces. I think I'm going to have a stronger force pulling down and a less pushing up. Then we're going to test it, and then we're going to put in our results in your notebook. So now, boys and girls, you're going to get another twirly bird pattern, all right? Be careful. This is the last one. And you have chosen what your variable is going to be. You're going to build another twirly bird, and then we're going to test it together. All right, I have built my 2 twirly birds. I have my standard, it says standard right there, and it has 1 paper clip. And it has the same length of wings, everything else. I didn't change anything. This is just the standard. And the variable that I'm testing is the number of paper clips. So for me, I added 2 paper clips to my twirly bird. I didn't make any other changes. Now that I have built my 2 twirly birds, I'm going to test them. And I need to test them at the same time so I can compare and contrast how they move. So I'm going to hold them both up at the same time, and I'm going to let go at the same time. Drop. Okay, I'm going to do it again because, boys and girls, do you remember when we tested with the magnets? Did we test just 1 time? We tested how many times? 3 times. So please drop your twirly bird at least 3 times. My result was the twirly bird with the extra paper clip fell a little bit faster. Just a little, not a lot. Now, boys and girls, based on that, do you think I could predict what would happen if I added a 3rd paper clip and a 4th paper clip? Right. Based on my tests so far, I could make a prediction and predict future motion, right? So please make sure that you write all of these things in your notebook. You've got this glued in. You've got all of those answered. And now I want to introduce another thing. From now on, boys and girls, I want us to ask a question of something you still want to know at the end of the science lesson. So you still have some time because we're going to do one more experiment before the end of today's lesson. Boys and girls, I've moved back down to the floor because this time we're going to be making some tops. So I'm going to take my wheel and axle system, and I'm going to take 1 wheel off. And so now I have a wheel at one end and a straw. And I'm going to move it up just a tiny bit. Try not to hold it in the middle and break it because you don't have very many straws. So now I have something like this. And this should remind you of something. It should remind you of a top. A top has a base, this is kind of the weight, and then it has an axis. Do you remember when we had it sideways, it was called a wheel and axle? Now this is called an axis. I'm gonna get my top, and I'm gonna give it a little spin. Okay, so if it's moving, we know it has unbalanced forces, right? Unbalanced forces. What are the forces that's making this top spin? So boys and girls, in order for something to turn, it has to have both a push and a pull at the same time. So, let's see. Put your hands together like this and push away with your right hand and pull with your left. So you're pushing and pulling, pushing and pulling. Now take your straw and put it between your hands and push and pull. Yeah! Just like we did with the twirly bird, we can make some changes to our top. Our standard top was the straw, and one disc. I'm trying to find out what is the best design for a top to make it spin a long time. So I added a second disc. When I add a second disc, it adds a little bit more weight. Now I'm gonna give it a push and a pull and see what happens. So boys and girls, I went back to my science notebook, and on the next page I put, what is the best design for a top? That's another focus question for us to think about. And what my answer was, a good top design will include weight at the bottom of the axis. It also helps to have a smooth surface for the top to move on. Now, remember I said I wanted you to ask another question, your own question. Part of your report card is, hey, you need to ask scientific questions. So every week you need to add, from now on, not in the past, but from now on, you need to add a question that you want to know about science. You could, you might want to ask a question about the twirly birds. You might want to ask a question about tops. I wrote a question, and my question was, are there other toys that use spinning or rotating because of gravity and wind resistance? All right, so make sure that from now on, every week, you're going to have a question in your science notebook. We will continue next week.